I need a pencil.
All right, so the ones that we have at the top of the paper are some of the reciprocal identities that we have. These are on the formula sheet as well, but there's also on the note sheet. So example 1 just wants us to use the trig identities above to rewrite each expression in one or more equivalent forms. So when you think of equivalent forms, you can almost think of like 1/2 and 2/4 are equivalent forms of a fraction. But we're going to be using formulas to write equivalent forms of trig functions. So for example, the sine of 45 degrees. We can go up here, we can find a formula that has the sine equals. So just filling in 45 where theta, this would be equal to 1 over the cosecant of 45. These are the same thing. They just look different. Just like 1/2 and 2/4 are the same thing. There are no other formulas that say sine equals, so that's it, only one. Next one is tangent, tangent of 50. So we go to our formulas, we look for anything that has a tangent equals, and this time there are 2 of them. So tangent is equal to 1 over the cotangent. So we would have first 1 over cotangent, and you'll just fill in the 50 where the theta is. And we also have that the tangent is equal to sine over cosine. So that would be sine of 50 degrees over cosine of 50 degrees. What we're going to be doing on the back is simplifying trig expressions. So sometimes it'll be more user-friendly to put it in one of the 2 forms because you'll see stuff canceling out or stuff that you'll be able to add together. Who thinks they know how we could rewrite the secant of 20? Looking at our formulas. The secant of 20 would equal what? Awesome.
1 over the cosine.
Good. 1 over the cosine. So not hard, but this is the basics to get us up to what's going to be look harder on the back. But this is how you start all the problems, is by rewriting. All right, try the next 3 on your own. Now we're going to also take into effect the complementary angle theorems. So if you remember from geometry, complementary angles were 2 angles that added to 90 degrees. Supplementary added to 180, but complementary adds to 90. So 2 angles are said to be complementary if they are both acute, meaning they're smaller than 90 each, and they sum to 90 degrees. So for example, 45 and 45. 60 and 30. 70 and 20. Anything that adds up to 90, both of them are less than. All right, find the value of each using your special angles chart. So the special angles chart is on the back of your formula sheet. Let's flip it over. And you'll notice that there is a sine column, a cosine column, and a tangent column. So you just have to go find the angle you want and then travel over to that column. So the sine of 45 degrees, you can see, is the square root of 2 over 2. The cosine of 45 degrees, so just go to the next box over, is also square root of 2 over 2. Now if you notice, 45 plus 45 gets us 90, meaning that these 2 angles are complementary. Let's see if the same thing happens for another pair of complementary angles. So find the sine of 30, which is 1/2. Then go find the cosine of 60. 60 cosine 1/2, okay? So anytime the angles add up to 90, the sine of one angle will be equal to the cosine of 90 minus that angle. So that's what these formulas tell you. These are called the complementary angle theorems. And this is kind of the proof of that one. The sine of 30 equals the cosine of 90 minus 30, which happens to be 60. So it just helps you to change the angle measures if you need to in an expression. So again, just practicing using these theorems to rewrite in equivalent forms. The sine of 45, we'll use this formula, would be equal to the cosine of 90 minus that 45. Which you don't have to show the work for this. Many of you will just do this in your head, but you would get cosine of 45. Okay, the next one is tangent of 50. And again, they tell you to use these theorems this time, not the ones on the top, just the complementary angle theorems. So this time we're going to use the tangent equals. So this would be equal to the cotangent of 90 minus 50, which is the cotangent of 40. All right, now the secant of pi thirds. There's two ways that you can do that. These expressions all work for radians, knowing that 90 is equal to pi halves. So if you want to leave it in radians, you would just change the formulas to all have pi halves instead of 90s. But I know a lot of you prefer to just change to degrees and then just use degrees. So either way, I think most of you like to convert, so I'll show the convert. So if we convert pi over 3 to degrees, two ways you can do it. Multiply by 180 over pi, or you could use your special angles chart. It's actually on the back of your table. So if you go down to pi thirds, you'll see that it's 60 degrees. So if we want to change the secant, we look up at our formulas and we have that it equals the cosecant of 90 minus 60, which would be the cosecant of 30. Now usually if I gave you the question in radians, I kind of want your answer in radians also. So you then have to convert it back just so we're consistent. Again, your special angle chart most of the time has the answer for you. So if you go find 30 degrees, right next to it, it says pi over 6. So that would be cosecant of pi over 6. Now, if you wanted to leave it in radians, you would have done cosecant of pi over 2 instead of 90 minus pi over 3. In order to add or subtract fractions, you would need a common denominator in case any of you want to do it this way. So you would need to multiply this one by 3 to get 6, and multiply this one by 2 to get 6. You'd have 3 pi minus 2 pi, which is 1 pi. So if you think that's easier, you're welcome to do it that way as well. All right, try the next 3 on your own. Use the complementary angle theorems above to rewrite these. These were the easy. All right, on the back, we're going to be given multiple operations: addition, subtraction, multiplication, division with trig functions. We are going to be asked to simplify and find the exact value of each expression. So we're going to use all the formulas from the front to simplify to get them to come out to usually be 0 or 1. Just so you know. Okay, the first thing you want to do is you want to check that the angles are the same. I'll say same degree or radian. Because if they are different numbers, you have to change those first before you can use any of your trig functions. The second step is to rewrite something using our formula sheet. And again, you're going to want to have the formula sheet out because now all the formulas we talked about are on the front of your notes and you don't have to be flipping back and forth. And there are multiple ways to do this and get the same answer because there are a lot of equivalent forms for these. So, for example, okay, you can either change the first one, tangent of 40, to something else, or you could change the second thing, sine 40 over cosine 40, to something. It's up to you, whichever one you want to do. For some reason, I think most of you think changing tangent is easiest because the formula says tangent equals. But if you notice, sine over cosine, if you can go backwards, is the tangent. So if you notice that, this actually could be simplified to be tangent. But in my years past, most students like to change this one. So we're going to rewrite, I'll do the first one in its equivalent form. There are two formulas for tangent. You would not want to do 1 over cotangent because the second thing that's up there doesn't have cotangent in it. You want them to look alike so that they're going to simplify. So I would use the first or the second formula, which is tangent of theta equals sine over cosine. So just filling in 40s, tangent of 40 equals sine 40 over cosine 40. So get rid of this and change it to sine 40 over cosine 40. This is equivalent, so we're not changing the value, we're just changing the way it looks. Again, think of equivalent fractions. 1/2, 3/6. Same thing, different look. Now, because this looks exactly like that, I'm not going to change it. I'm going to leave it like it is. We have the same thing minus itself. What would we get? 0. Now, had you have noticed it the other way around, which would be to change this one to be tangent of 40, you would end up getting tangent of 40 minus tangent of 40, which would also get you 0. So 2 different ways to do the same problem. But you need to use your trig identities to change some of these around to get them to look alike, and then they will simplify. Okay, next one. Check our angles first. 48, 48. Those are good. We need to change one. Don't change both. Okay, because then usually they don't have anything alike.
What was the second? Said check angles or same degree. What was the second one?
Check angles and then rewrite a trig function using your formula sheet. All right, so do you want to change tangent or cotangent? It does not matter. You pick. I heard both. Abby was the loudest. All right, cotangent. So cotangent, there's 2 formulas that are for cotangent on our sheet. Again, use your formula sheet. Which one do you think we would want to pick, the top one or the bottom one, based on what else is in that problem? The top one, because it already has a tangent in it, so we want it to have a tangent in it, and we'll see what happens. So I'm going to change this one to be 1 over tangent of 48, because those are equivalent. Now the first one I'm not going to change, but I am going to bring it straight down. And because it was not a fraction, I'm going to force it to be 1 by putting it over 1. And we're multiplying these. So the inverse of multiplying is dividing. So you can actually cancel these out. We're left with 1 over 1, which then is 1. Again, your answers are going to have to be usually 0 or 1 for the most part in this section. But you have to prove it. You can't just write the answer. All right, now the next one. Notice our angles are different. So you have to change the angles first. Would you like to change the 37 or the 53? It doesn't matter. Okay, next on 37. All right, so we're going to change the 37. Guess what it's going to become? 53. Okay. But we have to use a formula that I actually don't have up here. It's on your sheet. It is the complementary angles theorem that we did on the bottom of the front note sheet. The formula is that the sine of theta equals the cosine of 90 minus theta. So if I want to take the sine of 37, plugging in 37 for theta, I will get the cosine of 90 minus 37. Surprise, surprise, when we take 90 minus 37, we get 53. So we can take and cross out the sine 37 and replace it with cosine of 53. Now this is the only one that's not going to get us 0 or 1. Cosine of 53 plus cosine of 53 will not cancel each other out. If it was a minus, they would. But think about if you had like algebra, what would you get if you did x plus x? In algebra.
X squared.
No, that would be x times x.
2x.
You would get 2x. 1x plus 1x is 2x. So 1 cosine 53 plus 1 cosine 53 will be 2 cosine 53. If you did it the other way around, if you changed this to be 37, you would end up getting 2 sine 37. And both answers are always accepted on your quizzes, depending on which way you go. Okay, next one. First of all, we got radians. Second of all, we have different numbers. So we need to change both of those things. And most of you don't like radians, so we'll do change to degrees first. What is pi over 6 in degrees? 30. Remember, these are on the back of your sheet. These are in, a lot of these will be on that sheet. It's a quick conversion factor on the back. And this should be 60. Okay, so either way, they're not the same number, so we need to convert one of them to the other one. I'm just going to do the first one. So I'm going to change tangent of 30 to be 60. Remember, you can't just make it tangent of 60. You have to use your complementary angle theorems. So go on the front of your formula sheet and find the one that says tangent. So if we go to the front of our formula sheet, mine's blue, yours is white. It says tangent of theta equals cotangent of 90 minus theta. So if we want to change tangent of 30, we're going to plug 30 in for theta. So it'll be tangent of 30 equals cotangent, and if you want to do this in your head, if you're actually getting this, you don't have to show work for it. 90 minus 30 will get you 60. They're always going to end up matching because I made the problems that way. We should get cotangent of 60. So this changes now to cotangent of 60 minus, I would not change that one because it already is cotangent of 60. Remember, you want them to look alike. Anything minus itself will get us 0.
When in doubt, just put 0 or 1.
You will not get full credit for that, as I previously stated, as the work is required. Okay. Next one has 3 things. Notice 2 of them have the same number and 1 of them doesn't. So I would highly suggest that you leave the 43s alone and we change this one. Because then you don't have to change 2 things, you only have to change 1 to start out. So secant of 47 will be equal to what? Of 43. Look at your formula sheet. CFC. The formula on your formula sheet says under complementary angles that secant of theta equals the cosecant of 90 minus theta. So secant of 47 is equal to the cosecant of 90 minus 47, which magically becomes the cosecant of 43. And I usually have these so that they're going to match. You have to change the trig function along with changing it.
The first 90 minus 0 or 90 minus...
These are all on your formula sheet.
Oh.
There's a lot of them. You have to take the time to look. There's going to be a ton of stuff. The whole trig. And you want to use your formula sheet when you're doing your homework to know where to look so you get comfortable looking at the formula sheet. All right, so now we need to change stuff to get it to match. Right now, nothing is even close to matching. So let's start with the tangent. Tangent, we have 2 options. We have 1 over cotangent, or we have sine over cosine. Since none of the other ones have a cotangent in it, I'm thinking let's start with the bottom one. So I'm going to change tangent of 43 to be sine 43 over cosine 43. My sleeve would stop writing. Sine 43 over cosine 43. Okay, now remember, this is no longer secant. Make sure you cross that off. It's now cosecant of 43. So we go to our formula sheet. The cosecant is equal to 1 over the sine. So I'm going to take this and make it 1 over sine of 43. So all we're doing is filling that 43 in for theta from our formula sheet. So we can already see, right, sines are going to cancel out, which is like a good sign. Good sign. All right, cosine 43. Now you could change it to 1 over secant, but why? Because nothing has a secant in it. So I would leave this alone. And that's why some of this is going to be trial and error until you figure out, nothing cancels out, change it to something else. So I'm going to leave this cosine 43, but I'm going to put it over top of the 1 placeholder to make it a fraction. And now, since everything is being multiplied together, we can cross cancel. These would divide out, these would divide out, and we do get 1. 1 over 1, which is 1. Okay. We have 1 more. And then 2 closures for you guys to do.
You have homework?
We do not have homework today.
I wasn't here, Gator.
Okay. Which angle should we change? Huh? No, look at all the angles. Change the 50. That way you don't have to change both 40s. So if you have 3 or 4 angles, you only pick the 1, it's going to change. So sine 50 is equal to cosine of 90 let's change that. 90 minus theta. Wish I had those on my board like I have the other ones, but you guys have them all on your sheet. So sine 50 will be equal to cosine of 90 minus 50, which magically is cosine of 40. You just can't, every year some students will just make it like sine 40. Like you cannot just change the number and keep the trig sign the same, because that's a different value. But you can use the complementary angle theorems to change the angles along with the trig function. All right, now, I think this is what Cole was saying. Do the cotangent to change it first. So cotangent, we have two options for cotangent. 1 over tan or cosine over sine. Looking at what we have, which one do you think is the best option? Cosine over sine, because we already have cosine over sine. So we want it to look like what we have already. So we're going to change this one to cosine of 40 over sine of 40.
What if, couldn't you backtrack cosine of 40?
Yes, you could have changed this to be cotangent of 40. You get cotangent minus cotangent, we'll still get u 0. Yep, that's the other way to do it. I'm going to leave this other one alone because it's exactly what it was. When we take something minus the same exact something, we will get nothing, which is 0. But Cole is correct. If you wanted to, you could have changed this to be cotangent 40. Subtract those and you will get 0. All right, I'd like you guys to do the two closures. If you'd like to work with a partner and make this a little partner challenge out, you can. You have no homework tonight, even though it probably says you do, because that's going to be our in-class assignment for tomorrow.
We're not going to be here?
No, I will be here tomorrow. I will not be in my afternoon class today. So.
Oh, yeah. So you can change it. And